So in the previous lecture, we studied the, the gas and the gas pressure and the different units of the gas pressure to express in atmosphere and in Pascal and in of mercury. So today we are going to start the first uh, state of matter, that is the gases, and at the end we will derive the equation for the ideal gas law. And these are the basic law which you are learning right from your intermediate started. So here I am going to teach you another way. That means uh, how can we use these law to understand the behavior of the gas. So gases, that means there are four physical properties which of any gas can be defined, and these variables are the pressure, temperature, volume, and the number of the moles. So all the relationship between all four properties, actually it will going to drive an ideal gas law, and each one of is an individual law. So first we will discuss the relationship between all these four properties, which are going to be called different gas law, and later on we will move to the ideal gas law. But you will understand, let's suppose over here, this is actually these are the four physical properties which we have discussed in the previous slide. It is the pressure, volume, temperature, and mole. So you already know that actually we discussed the relationship of the volume with the pressure. That is one of the gas law. And then we discuss another relationship of the volume with the temperature. This is another law. And then we will also discuss another relationship, that means the volume with the mole. So actually, these are the three fundamental law, which later on we will combine, which will give you the ideal gas law. But important at your level, it is important to understand if this is the relationship of the pressure with the volume, or the volume with the temperature, or volume with the mole, or the number of moles, then there should also be a relationship between the pressure with the mole, pressure with the temperature, or mole with the temperature. So there are a few of the question marks are written over here. So at the end, you will be able to explore, or you can define all these question marks. So what would be the relationship between all these different relationship between all physical properties, and the pressure with the temperature, pressure with the mole, and the pressure with the volume. And similarly, each of the mole with the pressure, mole with the temperature, and mole with the volume. So this might be your second assignment. It is too early, but you must listen carefully. And of course, if you explain in the same way which I am going to explain to you right now, it would help you to get your 100% marks on this assignment. So first we will, one by one, I am going to teach you the law, and the purpose, another purpose of to to learn all these law is how can you verify whether your gas is ideal or it is the non-ideal. So what is coming out of this ideal, that means they are going to follow the behavior between the what would be the relationship between the volume with the temperature, and the volume with the mole, and the volume with the temperature. So let's start with the first one. This is called the Boyles Law, and it is the relationship between the volume and the pressure. So the first point to understand over here is you must always remember there is the relationship between the two physical properties, and remember We discussed the four physical properties in the previous slide, or in this slide. There are four physical properties. Now we are going to establish the relationship between any of the two physical properties. So when you are going to establish a relationship between two physical properties, the other two properties will remain the constant. So this is the first condition. Without this one, you cannot explain the correctly the relationship between any of the two physical properties. So this is the first assumption we are taking over here. And then in a similar way, we will move discussing the other laws. The first law is going to explain the relationship between the volume and the temperature. So first we will discuss the law and then we will apply this law. Actually, application of this law is important. So let's look if we have the gas. How can we verify that this gas is obeying the Boyles law or it is not going to obeying the Boyles law? So actually at your level 170 course, it is it is very important to know that what would be the verification of all of the laws which are going to study in this topic. So first let's look at these diagram. Here we are going to discuss the relationship between the volume and the pressure. Again, it is very simple to understand over here. Let's suppose I have the can having the volume, the gas, the volume over here is 1 liter and it is the pressure of 1 atmosphere. So there are the option. If I move towards the right, that means if I increase the pressure, to increase the pressure, now the pressure is 2 over here. That means the pressure is double as compared to the initial state. So this is my starting point over here. And I am going to increase the pressure and the pressure is double. So what is happening with the volume? So when you double the pressure, that means it is going to force on this piston. It is moving downward. As we have already learned, pressure is the force per unit area. That means if you increase the pressure in a unit area, it is going to exert the force on this piston. It is going to move to the downward direction. So it is happening for the maybe the ideal or the non-ideal gases as well. But what is important over here? What are the changes in the volume? The volume is going to decrease, of course, and it is decreased from 1 liter to the 0.5 liter. That means when you double the volume, when you double the pressure, there is a double decrease in the volume. That means the volume is halved over here. So that is the first relationship. That means the pressure is inversely proportional to the volume. When you increase the pressure, the volume is decreased. So there is another way. You may move from right to the left. So if you move to right to the left, that means you are going to decrease the pressure. So if you can compare these two values, so if you decrease the pressure, that means you are going to decrease by half the pressure. If your pressure is half, that means 2 divided by 2, it is 1. When you half the pressure, then your volume is double. So zero point 0.5 is the initial volume. It is going to be double. It is the 1.0 liter. So in either case, from left to right or from right to right. So there is the inverse relationship between the pressure and the volume, and there is a constant relationship. That it should not be zero point 0.4, it is not zero point 0.5, sorry, it is not zero point 0.6 or zero point 0.4, it is zero point 0.5. That means when it is double, it become half, and when this become half, the volume is double over here. So this is the explanation of the Boyle's law. Now we are going to consider this to apply in our main chemistry to understand the behavior of the gas. Again, the objective is how can we use this law to apply on different gases to verify that your gas is ideal or it is the non-ideal. So again, remember, if if your gas is ideal, that means it is ideal mean it is going to follow this relationship between the pressure and the volume. So first understand this we have discussed in the previous slide. Volume is inversely proportional to the pressure. So, or you can say this, now this is going to be dependent on the pressure. The Again, this is important to understand. Our controlling factor was the pressure. I increase the pressure, the volume is decreased. I relieve the pressure or I decrease the pressure, the volume become double. That means this is the volume is going to be depend on the pressure, and that's why I'm writing over here the volume is inversely proportional to the pressure because volume is going to depend on the pressure. This is the a dependent variable and this is the independent variable. That is, it is going to depend on the volume is going to depend on the pressure. That's why this is the dependent variable here over here. And when you remove this proportionality constant, so there should be a constant on the right hand side. This constant is called small k, and here you can call it the Boyle's law constant because this is having a constant value. Or you can simply write, because when you k multiply by 1, it will be, of course, the k v divided by k over p by using this very simple equation. So now you can also calculate the k, and the p is dividing over here in the denominator. This is going to multiply over here. So your k will be equal to pressure into volume. And remember, this condition must be at constant and temperature. Then you can establish this relationship, what I have explained over here. If your temperature is not constant or the number of moles are not constant, of course, you are not going to get this relationship as we have explained over here because temperature and number of moles are also going to influence the volume and the pressure. So this we have right at the start we discussed this. With the variable of the two, you must have the other two physical properties to remain at constant. So now I'm going to moving towards the objective. How can we see that your gas is the ideal or your this Boyle's law is going to be implemented on the gases? So I am again using a very simple equation as we have discussed in the chemical kinetics. You must remember there we also use the terminology. How can you verify it is the zero order reaction and what are the different methods to use to verify the zero order reaction? And in a similar way, here in the gases, we are going to consider a different law to verify that your gas is the ideal or the non-ideal. And it is very simple to understand. So I am going to use over here again, uh, uh, volume is inversely proportional to the pressure. Again, when you remove this proportionality sign, you have the constant on the right hand side, that is called the constant, plus C. This is also constant, but here we are going to use as the zero because there is no value of the C as we have the same equation over here. This is y, this is your m, and this is your x. So let me first explain this equation and then I will move to the verification of the ideal gas. So again, this y is taken on the, so this v or the volume is taken on the y-axis because this is the dependent variable on which it is going to depend on the pressure. If you, and this pressure is the independent variable, so it is taken at the x-axis. So first you have to decide which one is the your y-axis, which one is your x-axis. Again, the equation is written over here, y equal to k over p or y equal to 1 over p. And when these are the two factor, one is the k, other one is 1 over p, and this is the 1 over p is the variable. And whenever variable is going to multiply with the constant, and it must be on the x-axis. So that's why this k is your m is the slope, and 1 over p is the x, and v is the y. So y will be alone. That means independent variable is alone. It is not going to multiply with the any of the constant, but x-axis is going to multiply with the m. That's why this equation is called the y equal to mx, and this is the straight line equation. Maybe you can write plus 0 or not, it doesn't matter. Even if you write the 0, it is also going to show you there is no intercept. That means your intercept, this b or somewhere we use the c, is the intercept. So it is going to show you this is the intercept is 0. That means your equation is the y equal to mx. It is passing through the origin without intercept. Now look at these two graphs. The first is plotted between the volume and the pressure. Again, these two I have plotted over here, volume versus pressure. So if you start pressing this piston at the start, when you increase the pressure, this is going to be, the volume is going to decrease as given over here. And again, if you further increase the pressure, the volume is further going to decrease. So at the start, there is much more spaces between the gaseous molecules, as in some of the, I think, the previous uh, example we have discussed over here. Might be, okay, yes, this one. So look at the gas. Gas is having much more spaces between the molecules or the atom. That's why these are the gaseous molecules or the gaseous atom. And when you apply a pressure on it, then they are going to be collide to each other, having to exert the pressure on the walls of the container. So the space between the molecules become shorter and shorter. So what I'm going to teach over here is the actually what is the effect of the pressure at the start. It is more influence at the start, and then it is going to decrease because now the molecules of the gas are coming together and the space is becoming short and short, and then there is the less effect of the pressure on the volume. So this is shown over here. When you increase the pressure, there is sharp decrease in the volume, and when further this is going to be further increase the pressure, now the volume is becoming the difference of the volume is going to be decreased in a with a short range, and then at a certain limit, when you further increase the pressure, there is no further decrease in the volume. So this is happening, this is the general behavior for any of the gas. Now I am again recalling the objective. How can we apply this Boyle's law to verify that your gas is the ideal, or the gas is following the Boyle's law? These are the actually the objective of today class or today's content. By looking at this graph, it is difficult to understand whether this is the ideal gas or this is the non-ideal gas, or either this is the, it is following the Boyle's law or not following the Boyle's law, because every gas must have this relationship because it is the curve. Now look at this graph. This is the, now first is this graph is the curve, this is the straight line. So again, why you are getting the straight line in place of the curve? So the first reason is over here is look at the x-axis. Here it is the pressure, and here is 1 over P. This is again the pressure, but it is written over 1 over P. Here we are following the straight line equation because here V equal to K 1 over P, and over your x is the 1 over P, and 1 over P is has been displayed over here, and your volume is the is on y-axis. In a similar way, it is on the y-axis, And when you plot a graph between the volume and the pressure, then you have the straight line because this is following the straight line equation as shown over here. And it is passing through the origin because it is having the zero intercept, or you can say this is the y equal to mx plus zero intercept. So that's why it is passing through the origin. Now, the second point to understand over here is this is the positive slope. And this is again because your m is the slope and the slope over here is the k, and this is the positive slope. Positive slope means it is going to increase moving from downward to the upward. That is the positive slope. If it is moving to the downward, then it is the negative slope. So the slope is the positive. Now we are going to comment on the final conclusion, that how can we understand that your Boyle's law is going to be verified or it is going to be implemented on the ideal gas. And again, it is the same statement as we have already made during the verification of the zero order kinetics in the chemical kinetics. Again, if you have the state line passing through the origin with the positive slope, that means this gas is following the Boyle's law. And if it is following the Boyle's law, of course, this would be the ideal gas. So that is the final remarks on this graph. And again, if I ask if it is not the ideal gas or your Boyle's law is not implemented over here, then what would be the shape of this graph? So the shape would be, it should not be a straight line. It may be a curve, maybe curve like this way, or maybe the curve like this way. It depends on the changes being happened in the gases with the application of the gas law. So with the application of the pressure. So simply over here is, if it is, you get the straight line with the axis, must remember the axis. You have to mention volume versus 1 over P. If you first you have to mention the axis, then you have to explain the linearity of the graph. If you have not correctly mentioned the axis over here, then your statement about the straight line is wrong. So first is the appropriate mention the axis. So I am repeating over here again. You would say if you plot a graph with the volume on y-axis and the 1 over pressure on the x-axis, and the graph is passing through the origin with the positive slope and having a straight line, that means it is following the Boyle's law and your gas is the ideal gas. And vice versa, you can state if it is not, then it is not, your gas is not following the Boyle's law, or the gas may not be the ideal gas. So this is our today lecture, and important one by one, you must actually to understand, not only to memorize the relationship, okay, by increasing the volume, pressure would be the double or vice versa. But what important over here is the statement, what we have made over here, the statement, this is the relationship to understand correctly over here, and then the equation, how I have moved this equation to the straight line equation, and how I have used this straight line equation to plot a graph and to discuss the ideality of the gas and the application of the Boyle's law. So this is all about our today lecture.